This is a recording of how to use the Chameleon polymorphic cipher, and it's a 192-bit, and it is patented, and it is key-dependent encryption, and it was developed by Great Wall Information Security. We call it Great Wall InfoSec Sedan Berhad. And to start the encryption process, you go into the subdirectory and you double click on the CC192. CC192 is actually Chameleon Cipher 192-bit, and you want to encrypt a file, so you go and choose this file. I'm going to choose this R2 PNG, and you need a key. So I have the key.txt file. What's in this key.txt file is actually this one. It's actually called hello 123, and you need to overwrite a text file with the encrypted data. So I'm going to use cipher1 text to overwrite. And if we look here, we have the default value of the word size is 8 bits, but you can increase it to 32 bits if you want to. And the number of concurrent threads is, the default is 1, but you can increase it to 16 concurrent threads depending on your machine. And the minimum number of rounds is 4, but the actual number of rounds will be selected by the cipher itself. It's a key-dependent encryption, and that's the reason it was patented. And it will choose some extra rounds depending on the user key. And here you can get the Hamming distance, which is the number of changed bits and the number of zeros in the output file. So we are ready now to encrypt this image. This is the image we want to encrypt, so we're going to say okay, it was the time that for encryption is 0.313 second, and the number of extra rounds was 4, and here the average throughput is 26 megabit per second per round. The number of cycles per byte is 550 at frequency of 1.8 gigahertz. And if we look at the statistics, here we have 3.896 bits per byte, which is about 50%, which is okay. We like to have the number of changed bits to be almost half the number of bits. And the number of zeros is 50%. That means number of zeros equal to the number of ones, which is okay also. And let us see what happened to the encryption file, the encrypted file. Okay, this is okay. When you do encryption, you have to have a disconnected machine from the internet. If your machine is connected to the internet while you're doing encryption, it is vulnerable to certain type of attacks. Here, this is encrypted file. It's a big one, but and you can see it looks like Chinese character, but it's actually graphics. It's representation of the encrypted graphics or PNG. Okay, now you can copy this file on a flash memory or on a CD, and then send it to the receiver on a machine that's connected to the internet. And of course, the receiver should have a copy of the key text, exactly the one, and he should be using the same word size, the same number of concurrent threads, and the same number of minimum rounds. That's it. Let us go and try to decrypt this file. So I'm going to click the radio button, and I'm going to choose what? I'm going to choose the ciphertext, okay, to decrypt. And I need to overwrite a file that's of the same type, PNG. So I'm going to overwrite this file, the GWIS file. So I will go into it, is in the desktop. So GWIS is somewhere here. That's it. Okay, it will be overwritten by the decrypted file. now we are ready to do that, and everything is okay. Now I will start. Now I want you to watch what will happen to this image when the decryption is done. You see it has been changed into the original one, and the time of decryption is 0.234 seconds, and we can see some statistics, the Hamming distance, and the which is number of changed bits, and the number of zeros and ones is almost 50%. Okay, where is the decrypted now image? It looks like that, which is exactly the same like the encrypted image. And that's it. If you have questions, please send it to me. My name is Magdy Saeb. You can find a lot of the explanation of the Chameleon patent cipher, and there is a lot of explanation of cryptography in general on YouTube. Magdy Saeb, Magdy Saeb. Okay, thank you.